Okay, our objective today is to talk about more proportions, more similar figures, more congruent figures. I still have on the board that your test is either Friday or Monday for lesson 6.1 to 6.6. I have a feeling it's going to be Friday, especially if we get through the material that I have planned on to get through for today. So just, again, a heads up, excuse me, for you guys. That will be your last quiz for the semester for your report card grade. You will still have homework assignments that I will keep adding, but that will be your last quiz grade, okay, that will go in there. If it is Friday, we will do a review tomorrow, okay, in class. And if it's Monday, Friday will be our review day. So as you guys see, this stuff is not that bad. There have been chapters that have had much more difficult concepts in than at least the beginning of this. Now the back part of chapter 6, the probability, that's going to get to be a little bit more challenging. All right, so let's go over example 3 on the warm-up. This was in your notes on page 12. So I just want to ask you guys, what did you get for Z and Y? Okay, and then I want to talk about the triangle. Briar, what did you get for Y? Good. Charles, what did you get for Z? Good, 1.125. What kind of triangle is this? Doug? Okay. Okay, yes, good. So it's an isosceles triangle. Why do you know, or how do you know it's an isosceles triangle? Charles, how do we know? Good, so these are the same. So in an isosceles triangle, you have the two sides that are the same. What else is the same in an isosceles triangle? Sean, what else is the same? Yep, they're all acute angles, but what else is the same? Charles? Good. In geometry, you'll call these base angles. Those are always the same. Okay, so I just wanted you to be able to recognize that that is an isosceles triangle. Charles? Yes, you may. Okay, let's look at example 7. Okay, so example 7, besides the fact I forgot to tell you what you had to find, which were, or was the side WZ and angle W. What should you have done first on this one to make it a little bit easier? Annalise? This one, did you redraw? Okay. Okay, so Annalise, starting here and going this way, tell us how to label it, how you labeled it. Good job. Okay, and then you took ZY and wrote 16 meters, correct? Okay. So based on that, what is WZ? What is the side length, Zach, WZ? Did you get to that one, or? Good, how did you know that? Yep. Good job. We know they're congruent because they give us that congruent statement and tells us ABCD is congruent to WXYZ. Corresponding parts that we talked about yesterday are all congruent. Sides and angles, all congruent. Okay, questions on A. Okay, what about B? What's the measurement of angle W? Matt? Good, how did you know that? Yep. Good. Corresponding angles, if you have congruent figures, all corresponding angles are congruent. They are the exact same measure. Okay, any questions on the 2 warm-up problems before we go over homework? Okay, let's go over practice 6.4. I know there's some questions on this, especially that garden problem. Okay, so we will make sure we address those. In 1 through 6 yesterday when I was explaining this, I wanted you guys to draw a figure above 1 through 6 to use for all the problems. It's helpful to be able to visualize that, okay? So Briar, we'll start with you on number 1. Good, false. Sean, number 2. Good, true. Zach, number 3. Good. I'm at M, number 4. Good. Donatus, number 5. Good. Mary, number 6. Good. Awesome. So here were my answers, and here was my drawing. I just put it at the bottom, and I just used that diagram for all of these. Sometimes it's easy to me. It's easier to look at it with the drawing rather than just the labels. Mary? Yeah, if you didn't need the drawing, that's fine. Yeah, you do not have to. If you can see it or just look at the similarity statement, that's fine. Okay, number 7, you had to list all the corresponding angles and all the corresponding sides. So Emma H., can you list the corresponding angles for us? That's okay. You could try. Did you redraw it first? Oh, that's probably... Okay. So you guys will see on mine, I redrew the RSTU one right here. And I always cross off the old one. So redrawing it first is very helpful. So Matt, what are the corresponding angles? Well, you can put either the similar symbol or the congruent. Technically, in similar figures, all the angles are congruent, but either one's fine. Good. Good. Awesome. Perfect. And I have those up here, of course, with 3 letters, but the vertex is what Matt said. Okay, whatever's in the middle, those were the angles that were corresponding. Okay, who would like to tell us the sides that are corresponding, which means they're proportional? Ryer, go ahead. Good. Awesome. Okay, make sure for your sides, these ones have to have the similar symbol because they're proportional. Okay, they're not going to be exactly the same because the figures are similar. And you should have your line above it because they are segments. If you have the letters flipped around a little bit, that's okay. Annalise. No, you have to put one of those because you're writing down which ones are corresponding. So you have to indicate that somehow the sides have to be the similar symbol. The angles can be either one. However, we do know if they're similar figures that those angles are exactly the same. Okay, Alyssa? Yeah. For these, that's what I want you to write. You cannot write congruent for the sides because they're not congruent. They're proportional. So yeah, you need to put similar. Okay, let's go to number 8. Mary, what did you get for number 8? Good, 5 to 2. And I wrote my work up here. The directions on here I think were a little tricky for some of you. Basically, all they're asking is to set up the proportion of the corresponding sides, which is the same thing as the scale factor. So 4.5 goes with 1.8, 10 goes with 4. So if you write and simplify both of those, you get 5 over 2. Sean? Yeah. Well, that's all you had to do. There's only 2 sides, though. Oh, so you just had these. That's not too much work, right?
Well, it was sort of, well, whenever I got to like the harder stuff, it was like, I was like getting kind of confused. I think I was confusing myself.
Okay. Okay. Yeah, because it's very basic. As long as you guys understand the directions. Okay. Well, I'm glad you figured that out. Alyssa? Well, they asked you for the ratio of A to B. So the ratio of A to B is 5 over 2. On a test, I probably would mark that wrong. Homework, I'm okay with it, but make sure you just understand going from one to the other. Matt? Five. Right. Oh, no, neither. No. I see what you're saying. These are equal because they're corresponding sides. So all you do is simplify each of these. These are equal to 5 over 2. Remember, in similar figures, the side lengths are proportional. So when you simplify them, you're going to get the same fraction. Okay, so you're fine. 2.5 works if anyone has 2.5. Annalise? I mean, you can do it that way. That's technically the same thing. But when we did this in class yesterday, we did the big triangle, the base, to the small triangle base. Like we always did from one shape to another. But the way you did it is still the same proportion. No, you told me you had 2.5. Just, oh, yeah, no, it's 2.5. You can still set it up the other way. Okay, there's a lot of ways to set up a proportion, just like we talked about yesterday. Yep, yep, Charles? Right. Is that all you did? Yeah, that's all you had to do. Okay, go ahead, Charles. Yeah, no. Okay, Justin, number 9. 1 to 4.5? No, unless you just, oh, you just need to simplify that. Do 1 divided by 4.5, math, enter, and it'll change it to a fraction for you without decimals. Yeah, 2/9. So please make sure that you do not leave your fraction with a decimal. Please make sure you're always simplifying it. Okay, so both of those reduce to 2/9. Do not leave them as a decimal. Matt? Yeah, I don't know how you got 4/5. Oh, okay. That is wrong because 2 over 9 is not 4.5. 9 over 2 is 4.5. But they're asking you for the ratio from A to B. So it has to be A on top of B. No. A to B. They're switching them in all the problems. Which one's small and which one's big? Annalise? No. No, that's not right. It has to be A to B. A to B. That's what we just went over. A to B. A to B. Okay, number 10 should simplify, it would help if I had mine, to 1/6. Okay, so all of this reduces to 1/6. No matter which one you use, kind of like Charles said, you still get 1/6. Number 11 reduces to 10/7. Number 11 reduces to 10/7. Charles? Oh, yeah, like 10/7 or 10:7. Yeah, yeah, that's fine. Doug? I mean, yeah, but I prefer it as a fraction. I mean, it's equivalent, and it's simplified, but yeah, it works. I would not mark that wrong. If it was 1 over that, then that would be wrong. Okay, so number 12, the challenging one. Anyone want to tell us the answer to 8? I know this made you think. Emma H? Letter A? Good. And do you know what the ratio was? Good, which simplifies to? That's perfect. Okay, so that simplifies to 7/8. So here's what Emma H told us. 35 over 40 is equal to 49 over 56. Both of those reduce to 7/8. You are finding the ratio of, what was it? The garden to the walkway. So that's exactly what she did. She took the garden over walkway. Garden over walkway. These part of the numbers represented the garden. These numbers represented the walkway. Kind of a weird picture. Okay, what about B? B made you think too. Sean, what do you think? Awesome. So what does that reduce to? Because that's the actual question. You figured out the perimeters. which is correct. But now, what do the perimeters simplify to? Good, 7 to 8. So are they equal? Good. So yes, the ratios are the same. So you should have a yes there. The ratio of the perimeters reduced to 7/8, which is the same as what the dimensions of letter A reduced to. Charles. Oh, go for it. C. Good. So, oh yeah, that's all they asked you. Good. So 7 squared over 8 squared, so you get 49 over 64. You also could have had 1,715 over 2,240 if you found the area out originally but did not simplify. Yes, but I meant like if someone forgot to. Yes, you always have to simplify. Yeah. Mary. Okay, I don't know how. Do you know how you got 7 to 5? Because we set up the work up here. Okay, so you would find the ratio of garden to walkway. So you should have done 35 over 40, which is equal to 49 over 56. Garden to walkway. So I'm guessing you used the wrong fractions. Okay? Are you okay? Okay, Alyssa? The garden right here. 35, 49. I know, the drawing is confusing. And then the walkway was 56 and 40. Actually, they told you in the directions. Yeah, they told you if you read the problem, they told you that the garden was 49 by 35. Do you see that? And then the walkway was 56 by 40. Do you see that? Okay. It still was confusing. Yeah, that's okay. Just wanted to bring that to your attention. But the drawing, to go back to that, the drawing is kind of weird how they labeled that. Okay, are you okay with the other ones now that you know that? Okay, Mary? Okay, who can answer that? Can anyone answer that for A? Why did we do 35 and 40 and 49 and 56? Annalise, why? Yes. So you're comparing garden and walkway. So, yeah, garden's right here. But the ratio has to be set up as garden to walkway. So this has to be the garden number, this has to be the walkway number. This has to be the garden number, this has to be the walkway number. Garden, walkway. Because your ratio has to be garden to walkway, not garden to garden. Very different. You're not comparing the same thing. Remember, a ratio is comparing two different quantities by definition. You're never going to compare the same thing. Okay, Sean? No. No, those are just all besides this one, those are just the options that you could have. Did you understand how to get to that? Okay. Annalise? 7/10. You're welcome. Okay, anyone else on homework? Okay, is everyone now clear on numbers 8 through 11, that they were much easier? You just had to find the ratio? Okay, give me a thumbs up, thumbs middle, thumbs down. We're doing more of this today because the problems are very similar. Okay, thank you. All right, let's go to our notes. I want you to open up to page 14. Okay, so like I said, the lesson's pretty similar today to what we did yesterday. Just we have to set up more proportions in this one. So once you're on page 14, our objective is to find unknown side lengths of similar figures. Before we start, what, Charles? It's very similar. Like I said, the book kind of just runs all these together. Okay, who can remind us, if you have two similar figures, what do you know about them just by hearing that word similar? So what do you know about two figures if you know they're similar? Justin, what's one thing we know? Good. They don't necessarily have the same sides, but the same shape. Good. What else can we say, Charles? Awesome. The angles are exactly the same. Emma M. Good. They're like but not congruent. Mary. Good. The sides are proportional. The angles are exactly the same. Very important that you remember that. Similar figures. Angles are the same. Sides are proportional. Okay, what about congruent? What do you know about two congruent figures? Doug, what do we know about congruent figures? And? Awesome. Congruent. Every single thing is the same. Okay? That's your symbol for similar. This is the symbol for congruent. Annalise? No. They're proportional. No, that won't happen. They would be congruent if they were both 12. Okay? If they're all the same, they're congruent. If they're proportional on your sides, they're going to be similar. Okay? All right, so let's skip that. Is that the wrong thing? Oh, we already went over all that. Okay, let's go to example 1. Okay, don't worry about the warm-up on that page. Okay, example 1. We are given that ABCD is similar to EFGH. We need to find EH. What should we do first on example 1? Emma H? Yeah, so I'm going to cross this one off. I'm going to keep ABCD the way it is, and I'm going to draw another figure. I want you guys to do the same thing. So ABCD is similar to EFGH. Remember, make sure you're going either clockwise or counterclockwise. Don't skip around when you're labeling. FG is 30 inches. EH is X. So we need to find EH. So I want you to set up a proportion. What's one proportion that we can use to find X? Annalise, what's one proportion? Good, that works. What's another proportion we could have used? Matt? Yep. Good. Okay, so you're just saying just find the scale factor as another option. Okay, I thought you were going to keep going. Yes, you can find the scale factor, and there's also a couple other proportions you could use. It doesn't matter what way you do it, but please make sure that you know how to set up a proportion. Mary? No, you asked me that before. No. Remember what I said? You don't have to. You can turn your head sideways. Just make sure you don't mess up on a test. If you're not redrawing it, please make sure that you're confident with how to do that. Okay, so use cross product solve. We get 12x equals 480. What's x? So how many inches, Briar? Good. 40 inches is the measurement of side x. Oh, definitely, yeah. Yes. Yeah, you can do a lot of proportions. Yep, you could also do 16 over 12 equals x over 30. You could also do 30 over 12 equals x over 16. There's a lot of options. Doug, question? Okay, well, let me go to it first, okay? Okay, let's go to example 2. Okay, example 2, we need to write and solve a proportion. And it says in each pair of the triangles, they are similar. We need to find the unknown height h. So in A, we have 2 triangles in 1. So what I would prefer that you do is draw them. Here's the bigger triangle. So I'm going to take this and I'm going to draw it, okay? Our bigger triangle, the base is h, the height is 12. The smaller triangle on the inside is right here. I'm going to redraw that. The height is 8, the base is 4. So does everyone see how there's 2 triangles in 1? Annalise? No, that's the height. See these triangles are like laying on the side. If you rotate them up, they'll be standing. I just rotate them so they're standing up. You don't have to do that. You can keep them laying down. But I rotated them up because this side's taller. So I always think of this as the height because it's longer. Well, you can consider it the height. I know that the problem says height for H, but when I redraw triangles, I always flip them around and put the taller side as the height. No, no, nope, doesn't matter. Charles? No, it's not. No, it's... Oh, then maybe the copy got messed up on yours, because on my notes it does. Okay, hold on, we'll get there. Hold on. Okay, so A, what's one proportion you can use? Regardless of how you draw them, what's one proportion you can use? Matt? Okay, but let's not simplify yet, but yes, that works. What you said is correct. So 8 over 4 equals 12 over H is 1. Matt simplified this to 2 over 1. That works as well. Jeremy? Whoa, we're on A. We're on A. Are you with me on A? Okay, are you guys all with me on A? Okay, Doug, question? Hold on, we don't need to worry about that yet, so hold on, okay? Okay, stay on task, please. Okay, use cross product solve. What do we get for H in letter A? Emma H? Good, 6 inches. Now, let me just real quick go back to this one. If you don't like drawing them how I did, you may also take the bigger triangle, keep it the way that it is. So this would be your bigger triangle. Here's H, here's 12. Your smaller triangle, 4 and 8. Whether you draw them like this or like this, you get the exact same proportion. Give me a head nod. Do you guys understand how there's 2 ways to draw it? Okay, you guys just look tired today, making sure you're with me. All right, let's go to B. Okay, letter B, the 22 should be labeled as millimeters. Charles, is that why you were asking me that? Okay, yeah, there was just a typo there, or it was missing, I should say. So let's redraw these. There's 2 triangles. I will keep them the same way this time. Let's go with the bigger triangle first. Okay, our bigger triangle, we have 10 millimeters, and this is 36 millimeters. Let's take our smaller triangle, which is on the inside. Okay, we have H, and then 22 millimeters. So do you have to redraw these? No, you don't have to. But in geometry, when you see problems like this, they will get harder. Okay, what's one proportion? Emma M, what's one proportion we can use? Equals? Good, equal H over 22. After you use cross products and solve, so if you haven't done that already, go ahead and use cross products and solve, and tell me what you get. This one's not nice. So use cross product solve, put your hand up once you get an answer. Adam, do you get it? Okay. Adam, what is in your hand? Okay, why don't you have a pencil? It's broken. Okay, that's fine. Please bring a working pencil tomorrow, okay? Justin, what'd you get? Good, 6.1 repeating. You may also leave it as a fraction or improper fraction, or mixed number, I should say. Questions on that one? Okay, let's do another shadow problem like we did yesterday. So example 3. It says, a flower that is 2.5 centimeters tall casts a shadow that is 7.5 centimeters long. At the same time, another flower casts a shadow that is 12 centimeters long. What is the height of the other flower? I want you to draw 2 triangles, kind of like I have with the flowers up here. Label your triangles, and then set up a proportion. Don't solve yet. So go ahead and draw 2 triangles to indicate the large flower, the small flower, and then label them, set up a proportion, but don't solve yet. Yes, on that one it does. Okay. Think about what we talked about yesterday with the height and the shadow. Good. Oh, that's fine. You don't have to use them if they confuse you. Okay. So on the big flower, what can we label? On the large flower, MH? The big flower. You know what I mean? Good. And what about the height? Good. H or X, whatever you want to put. I always use X. Okay, Doug, what about the small flower? How do we label that one? Good job. Okay, so here's how we label them. Yesterday, remember we talked about the shadows on the bottom. How tall it is H is the height. Now, if you prefer to kind of flip them around and draw them on the side, then you would have the shadow as the height and the height as the shadow. You could do that. It doesn't matter as long as you're consistent. If you draw them the normal way, here's what they look like. Charles? Yes. So technically the shadow should be longer than the height. I did not draw them, of course, in proportion. And when you guys take geometry, that's going to drive you crazy because I know it bothers me. They don't always draw figures proportional, or they say it's not drawn to scale. They do that all the time to throw students off. So yes, Charles, that would make most sense, but they don't always do that in the book, so I try not to always do that. Sean? No. Well, as long as you did the bigger flower as these dimensions, then you're fine. Okay, one proportion we can use is x over 12 equals 2.5 over 7.5. So if you haven't already, use cross products and solve so we can find the height of the larger flower, which, yes, is smaller than the shadow. Did you guys all get it? Okay, Alyssa, what'd you get? Good. So the height of the larger one is 4 centimeters. Doug? Yeah, we're not doing it because there's not enough information. Okay, just stay with me because some of the problems we're not going to do. Matt? Yes. Mary? They are, you're right. Annalise? Yep. Yeah, but did you hear what I said before? If you flip them around, and if you put the shadow here and the height here, that's okay, as long as you're consistent. So if you put the shadow here on one, you have to put the shadow here on another. If you put the height here on one, you have to put the height here on another. Okay? All right, let's flip your notes to page 16. Okay, we're going to talk a little bit about, at least start to talk about scale drawings, because in my mind this is very similar. So what is a scale drawing? Or when would you see a scale drawing? Briar, what is it? Good, two drawings that are scaled to each other. So what's an example in life? Justin? Good, a map. If we did not scale down the United States to make a map, could you actually make a map of the U.S. if you did not scale it down? No. Okay, yes, true, but it would, yeah, that would be crazy. It would cover everything, okay? So you have to use scale drawings when you're making maps. When else would you see scale drawings or scale models? Sean? Okay. Hmm. Nice. Yep. nice. Yeah, I did that when I was in, I think it was grade school. That's neat. Mary? Good. So if someone's building a house, one of my friends just built a house, you have to have an architecture map, okay, blueprints of what you want that house to look like, dimensions of every room, of every detail, okay? That has to be scaled down. It can't be the actual size of your house. Justin? Yeah. Yeah, not enlarged. Yeah, like if I buy strawberries, like frozen strawberries or fresh ones, they'll like show a picture of it, and sometimes it'll say not drawn to scale or not the actual size. You're exactly right. I can't think of what else I see that. There's a lot of times in grocery stores or even just stores. Right, yes. Crackers, cereal, there's a lot of things. Good idea. I didn't even think about that one. Mary? Yes, photographs are scaled down. You're exactly right. Especially photographs of huge things. If it's a photograph of something small, it might be the exact same, but if it's huge, good idea. You're exactly right. Adam? Yeah, we're not doing that. Just stay with me, okay? Don't get off task. Briar? Good. Model planes, boats, cars. You have to scale those down, okay, to figure out exactly how you're designing them. MH, is that a hand? Good. Oh, oh, perfect. If I could draw, we would do that in math, but I can't draw. That's great. Annalise, bless you. Oh, nice. All right, so great. You guys, those are great, great examples. So let's break down a couple definitions here, then we'll do a couple examples. So what actually is a scale? Well, our book tells us that a scale gives the relationship between the drawing or model's dimensions. So a scale gives the relationship between the drawings or model's dimensions. So like some of you guys said, it might be ×2. You might have to enlarge it. You might have to shrink it to make it 1/3 of the size, okay, or 2/5 of the size. Scale factors come into play again when you're talking about scales, scale drawings, scale models. So that's why I like to do these lessons together. They all are related so closely that we could just keep going. If I had you guys for an hour or two, we could have done the whole thing, right? Just what you want to do. Okay, so that's scale. Scale drawing, a two-dimensional drawing that is similar to the object it represents. Two-dimensional drawing that is similar to the object it represents. We talked a lot about this. You guys gave some great examples of scale drawings. Uh, 2 years ago when I taught this class, a lot of the students had questions about the difference between two-dimensional, three-dimensional, four-dimensional, what it looks like. I have some examples up on the smartboard that I'll show you in a minute. Some pretty cool things. You will learn a lot about three-dimensional objects in Calculus 2 and Calculus 3. Adam? Oh, nice. Very cool. Hold on one second. Okay. Okay, one more definition, then I'll show you some of those. Scale model, a three-dimensional model that is similar to the object it represents. So scale model, three-dimensional model that is similar to the object it represents. Annalise? Yeah, you can shorten the notes anytime. This never has to be verbatim what I have on the smartboard. That's where you learn good note-taking skills, is to shorten things. Emma? Sorry, I didn't know I thought you were asking a question. So scale model, three-dimensional model that is similar to the object it represents. Emma H? Yeah, that's fine. You guys can shorten, change. Most of the stuff I get from the book, so. Okay, so here's a pretty cool picture of a four-dimensional object. Show you guys a couple. Well, it's hard. It is four-dimensional, Donatus, but you have to look at it. It's technically in the air, in the sky. There are four dimensions to it. It's just very hard to tell by looking at it with all the stuff going through it. Annalise? I'm not going to answer that yet. This is a calculus thing that you'll learn about all that. It would take me longer than a minute to tell you that. I found these online, so yeah, these are real. Yes. So here's four dimensions again, but showing you more so on a graph. And again, this is, Donatus, did you hear what I just said? This is calculus stuff. I'm just showing you, okay? I'm just showing you. Okay. Oh, thank you. Thank you. Okay. Here's, well, this one's not very good, but that's supposed to be four-dimensional. Yeah. This is common sense, right? Now this you will see in Calc 2. You will actually graph lines and objects on a three-dimensional plane. So in this class, in algebra and geometry, it's kind of boring because you only learn that there's an x and a y axis. Well, guess what? There's also a z. So we lie to you in algebra, geometry, and algebra 2, not telling you that there's also a z axis. I'm just kidding. We don't lie. It just you can't learn it till you get a little bit older. Charles? You'll get there. Just hold that thought. It's more Charles, it's more complicated than X, Y, Z. If it was V, Annalise, I would tell you that's not more complicated than X, Y, Z. Sean? It gets different when you get to calculus. Three dimensions, that's pretty common sense, right? You guys know that's more common. So anyways, there's just some pictures. Okay, listen, I'm going to hold off on the problems using scales. So I'm thinking your quiz is probably going to be Monday, okay, because I didn't get through that. So open up your homework packet to practice 6.5, and I need to explain this. So Adam, open up your homework packet. Okay, you are going to do all of them, but I need to do one with you. So please, everyone listen. Okay, open up your homework packet to 6.5. Okay, once you're there, you're going to do all of it, okay? I suggest that you redraw some of them. We are going to do number 6 together, just setting it up, because if I don't, I know you guys are not all going to get this if I don't get it started with you. You're doing all, I'm just starting it with you. I'm not doing the whole thing, Adam. Right now. Okay. Once you're ready, let's take a look at number 6. ABCD is similar to AGFE. So there's a square, well, a rectangle within a rectangle. Okay? So I'm first we're going to take them and we're going to draw them. Every single one of you needs to draw this with me. So we have A, B, C, D. And then the other one, A, G, F, E. Okay, you guys are going to label with me. Everyone needs to draw that, even if you don't like drawing things. This one's hard. Okay, let's start with the big one. What is side AB? What is side AB? Donatus? Can you please explain that to us? Why? Good job. You guys are so smart. Awesome. What is side AD on the big one? Alyssa? Perfect. 33. Would you guys have figured that out without me doing this? Okay. I wasn't sure. I figured most of you would, but just in case. Okay, what about the small one? What is AG? Mary? Good. What is AE? AE, Matt? Good. 24. Okay. Before I do a proportion with you, is everyone okay on redrawing and labeling when it's like this? Annalise? No, that's x. You never use an x for multiplication. It's always a dot. Okay, what's one proportion we can use? What's one proportion, Mary? Good job. So is everyone okay with, 24, not 44, sorry. Is everyone okay with solving this using cross products? Sean? Equals 16 over 24, yep. Okay. We do have to get packed up. So is everyone okay with solving this using cross products? Okay, that's as difficult as it will get. Okay, that's it. All that for homework. There's a back and a front. Adam, do you have it today? Okay. What? No, guys, it's one. Oh, yeah, sorry. Yeah, it's 1 through 9. 1 through 9 is all of it. So it shouldn't take you too long. Okay, tomorrow we'll talk more about scale factors and conversion factors.